Hi kids, today our topic of discussion is probability from class 10. So in simple term, we define probability as measure of uncertainty. Take an example. Suppose you pay rupees 5 to throw a die and there's a condition that if one turns up, instead of rupees 5 you get rupees 20. But if the other number turns up, you get nothing. So should you play that game? And what are your chances of winning? Probability has an answer. Okay? Now before going into probability, there are certain terms we should be aware of. First, an experiment. Experiment. What is an experiment? An action which results in some well-defined outcomes is known as experiment. Suppose you toss a coin, so you know the outcomes well defined, that is either you'll get a head or you'll get a tail. So that is an experiment. Okay, now there's random experiment. Now what is random experiment? An experiment with more than one possible outcome, and the outcomes cannot be predicted in advance, is known as a random experiment. For example, when you toss a coin, that's an experiment, random experiment, you can say, tossing a coin. So you don't know the outcome. You can assume that maybe it can come head or tail, but 100% surely you cannot say that head will come. So that's a random experiment. Again, suppose throwing a die or picking a card from a deck of 52 playing cards. These are all my random experiment. Now this one term which is very important, sample space. Write all these, okay? This will be very important while doing the sums. The sample space, the collection of all possible outcomes is known as your sample space. For example, when you toss a coin, you'll get either a head or a tail. So that's your sample space represented by S. The experiment is throwing a coin. The sample space is H, represents a head, or T represents a tail. Whenever you write sample space, you write in curly bracket. Suppose you throw a die, then your sample space while throwing a die will be 1, 2, 3, 4, 5, 6. So these are the sample space. Am I clear what is sample space? All the possible outcomes of an experiment. Now comes event. Now, what is event? Simple. A subset of the sample space is known as an event. For example, when you throw a die, the sample space is 1, 2, 3, 4, 5, 6. So one of our event can be getting an odd number. That is, either you should get 1, 3 or 5. So this is your event, getting an odd number or getting an even number. That's 2, 4, 6. That is another event. There can be many events associated with an experiment. I've given 2 over here. Okay. Now, one more thing. When do you say that the event has occurred? Occurrence of an event. When the outcome satisfies the condition or the event given during an experiment, which means suppose your event was getting an odd number and you throw a die and 3 turns up, then your event has occurred. If 4 turns up, then your event has not occurred. Am I clear? Then we have favorable outcomes. Favorable outcomes. So what are my favorable outcomes? We can say simple, the outcomes which ensures the occurrence of the event. The occurrence of the event is known as favorable outcome. For example, throwing a die is an experiment. 1, 2, 3, 4, 5, 6. This collection of numbers, of course, in curly bracket. Sample space is always written in curly bracket. Is your sample space. Getting an odd number is your event. And 1, 3, 5 are your favorable outcomes. Am I clear? One more thing. Equally likely outcomes. Equally likely outcomes. Now, what is equally likely outcomes? Just look over here, I'll write it. If there is no reason for any one outcome to occur in preference of other outcome, then it is known as equally likely outcomes. What do you mean by that? Take an example. Suppose you throw a die, then the sample space is 1, 2, 3, 4, 5, 6. The chances of appearing 1, 2, 3, 4, 5, 6 are all equal. Am I clear? But take another case. You take a bag, you put 5 blue balls and 1 red balls. Then you try to pick a ball without seeing. Then the chances of blue ball coming out of the bag is more as compared to the red ball, because the number of red ball is less as compared to the blue ball. So this is not an equally likely outcome, but this is an equally likely outcomes. Right? These points are very important. Now, based on this, now, if these terms are clear, I'll give you the mathematical expression for the probability of an event. So now you can write the mathematical expression for the probability of an event. Probability of an event, suppose E, is given by PE is equal to favorable outcomes, we have done, favorable outcomes by total number of outcomes. Take a very simple example. Suppose I'll tell you, I throw a dice, so the sample space is 1, 2, 3, 4, 5, 6. What is the probability of getting an even number? So your event is an even number. So probability of getting an even number, PE. See, favorable outcome will be 2, 4 and 6. There are 3 favorable outcomes. and the total number of outcome is 1, 2, 3, 4, 5, 6. So getting an even number, the probability will be 1 by 2. Am I clear? So probability of event E is favorable outcome by total number of outcomes. And the value of probability of any event lies between 0 and 1, both included. Why 0 and 1? Why 0? Because there can be an event which is not possible in an experiment. For example, if I throw a die and I'll tell you the event is to get a number greater than 6. So the probability will be 0. Probability 1, I'll tell you. If I throw a die and I'll tell you the event is a number less than 7. So there will be 6 favorable outcome and total outcome is 6. So 6 by 6 will be 1, which is probability will be 1 in that case. And the value of probability of event lies from 0 to 1, both included. Now, few more terms, sure event. An event which will always occur, is known as a sure event. For example, if I give you an event, when I throw a die, a number suppose less than 7. So that's a sure event, isn't it? Next, I'll tell you about an impossible event. Impossible event. See, in the sure event, suppose E is an event over here. If you want to find the probability of this sure event, now a number less than 7. See, 1, 2, 3, 4, 5, 6. There are 6 favorable outcome, and the total number outcome is 6, which is probability will be 1 in this scenario, isn't it? Impossible event. An event which never happens. For example, when we throw a die and I'll tell you that is an event, suppose a number greater than 7. Now if you see, number of favorable outcome will be 0 because there is no number greater than 7, isn't it? So you can say probability of an impossible event is number of favorable outcome, which is 0, by total outcome, which is 6. So 0. Am I clear? Now, elementary event. An event with one favorable outcome. An event with one favorable outcome. In the same case, I'll say is an event a number less than 2 when you throw a die. There's only one favorable outcome, isn't it? So the probability will be 1 by 6. So that's your elementary event. Now, related to elementary only, compound event. An event having more than one favorable outcome. If there are more than one favorable outcome, then it is known as a compound event. For example, getting an even number when you throw a die, it's a compound event, isn't it? Then one more is there, which is complementary event. Complementary event. Now look carefully, this is important. Suppose we have an event E. Suppose an event E is an even number. Okay? So the event which is not E, the event which is not E is known as complementary event of E. For example, I told you I'll take an event. Suppose my event is when I throw a die getting an even number. Then the complementary event, that is EC, okay, or E dash or E bar, is not an even number. And probability of an event plus probability of the complementary event will be equal to 1 always. So probability of getting an even number is half. So probability of not getting an even number will be 1 minus half, isn't it? P E bar will be 1 minus P of E, isn't it? So it will be 1 minus half, that's half. Am I clear? Now we'll discuss few cases where we need to see the total number of outcomes before we move to do the sums. Copy all these are very important. Now we'll discuss the outcomes of these cases. First of all, tossing a coin, one coin, we know the outcomes. The sample space will be a head or a tail. Okay? Toss a coin 2 times or tossing 2 coins simultaneously, is the meaning is same. So in that case, suppose you take 2 coins and you toss together. Okay? Then on one you can take a head and the other also you can take a head, or H and the other turns up tail, or the first one tail, the second one head, the first one tail, the second one tail. So these are the 4 outcomes possible when you toss a coin 2 times or tossing 2 coins simultaneously. So the sample space will be H H comma H T T H T T. Am I clear? Now, tossing a coin thrice or tossing 3 coins simultaneously at the same time. Then how many outcomes are possible? Okay, we'll see that. A very easy way. See, number of outcomes, total outcomes, when you toss a coin will be 2 to the power n, where n is the number of coins. So when you took one coin, one coin, it will be 2 to the power 1, that's 2 outcome. When you take 2 coin, it will be 2 square, that's 4 outcome. When you take 3 coins, it will be 2 cube, that's 8 outcome. Okay, there will be 8 outcomes. Now, how to write the outcomes? I'll tell you very easy. There are 8 outcomes. Write head 4 times. Just look carefully. Tail 4 times. Then, the next position. Write head 2 times. Tail 2 times. And continue. Alternate. In the last place, there are 3 coins, head, tail, head, tail, head, tail, like this. So see, you get total number of outcomes as 8. These are the only possible outcomes. Okay? So it will be H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, then you have T, T, H, I'll just rub this, then the last one is T, 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 T. So these are my outcomes. Remember, whenever you are writing the sample space, use the curly bracket. Am I clear? Now, throwing a die, we know, if you throw a die, your sample space will be 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. But throwing 2 dice together, So if you throw two dice together, the total number of outcomes will be 6 multiplied by 6, that is 36 outcomes. And what are the outcomes? How do we know? Just look over here. Make a grid. 6 rows and 6 columns like this. See. 1, 2, 3, 4, 5, 6. For the first die, 1, 2, 3, 4, 5, 6. Now for the second one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now the outcomes. See, it can be 1, 1. It can be 1, 2, 1, 3, 1, 4. Isn't it? 1, 5, 1, 6. Which means I'm just removing the commas. 1, 1 means it's not 11. 1, 1 means on the first die you have 1. In the second die, on the top of the second die also you have 1. On the first, this I'm taking as the first die and this as the second die. On the first die you have 1. On the second die you have 3, like this. So over here 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5 and 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So your total outcome will be 36. These, look carefully. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are known as doublet. Why? Because on both the faces we have the same numbers. Okay. Now, one more thing I need to discuss is the pack of 52 cards. Now when you talk about a pack of playing cards, it has 52 cards in total with 4 different suits, and each suits have 13 cards. Okay, what are they? Look at this. You have heart, which is red in color. You have diamond cards, which is again red in color. Then you have spade, which is black in color, which is like something like this. And then you have club, which is like this. They're all 13 in numbers. Now when you talk about red of hearts, suppose, okay, it has 13 cards, out of which 3 are face card. King, Queen, Jack. These are your face cards. There is a ace, and these 4 are known as honor card. Honor cards. Then you have numbered card, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 9 numbered card. These are your numbered card. There's 1 ace and 3 face card in all. So if you talk about total number of face card, 3 in each suit. So there will be 12, 4 3s are 12 face cards. So if I tell you what is the probability of getting a face card, so 3, 6, 9, 12, 12 out of 52, 4 3 times, 4 13 times. If I tell you what is the probability of getting a black ace, now black ace, which means we're talking about these two, club and spade. So one from here, one from here. So there are 2 favorable outcome, 52, that's 1 by 26. If I say what is the probability of getting a red color numbered card, now there are 9 and 9 over here, 18 red numbered card, so which will be 18 by 52, that's 2 9 times, 226 times. Am I clear? Just remember this composition. What are the cards in each suit? Now let us solve sums from ML Aggarwal exercise 22. Now look at sum number 1 from exercise 22, probability ML Aggarwal, class 10. A bag contains a red ball, so there is one red ball, a blue ball, one blue ball, and a yellow ball, and one yellow ball. All the balls being of the same size. Anjali takes out a ball from the bag without looking into it. What is the probability that she takes out a yellow ball? So probability of taking out a yellow ball, a red ball, probability of taking out a red ball, and probability of taking out a blue ball. Very simple. When you take out yellow ball, see, one favorable outcome and total number of outcomes is 3. Same fashion, when we take out red ball, probability of red ball, one favorable outcome, total number of outcome is 3. Blue ball, one favorable outcome, total number of outcome is 3. So 1 by 3. Probability of an event is number of favorable outcome by total number of outcome. This is the only formula we have done till now. Total number of outcome. Done. Number 2. A box contains 600 screws. 1/10 are rusted. So number of rusted screws will be 1/10 of 600. That's 60 screws are rusted. So number of good screws which are not rusted, I should say, 600 minus 60, that's 540. One screw is taken out at random from this box. Find the probability that is a good screw. So probability of good screw. So your favorable outcome is 540 and your total number of outcome is 600, isn't it? Because there are 600 screw in total. So that's 6 9 times, 6 10 times. So 9 by 10. Am I clear? Now look at the next sum. Now look at number 3. In a lottery there are 5 prize tickets. There are 5 prize tickets and 995 blank ticket. Blank tickets. Okay. A person buys a lottery ticket. Find the probability of his winning a prize. So if you get one out of these 5, you win. Okay. Now look. Probability of winning a prize. Number of favorable outcome, which is 5. By total outcome, and total outcome is 1000, isn't it? So that's 1 by 200, isn't it? Look at number 4. 12 defective pens, 12, I'm writing defective pens, are accidentally mixed with 132 good ones. Good ones, okay? If it is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Probability of the pen taken out is a good one. Now when you add this, it is 144. So number of favorable outcome is 12. And total number of outcome is 144, which is 12 1 times, 12 12 times. So 1 by 12. Clear? Look at this one, number 5. Interesting. If the probability of winning a game is 5 by 11, what is the probability of losing? Now look carefully. Suppose this event I write as E, winning. So probability of winning is 5 by 11. So probability of not winning, which is P, E bar, we need to find. This event will not happen. Complementary event, E bar. Okay. Now we know probability of an event plus probability of that complementary event not happening is 1, which means probability of not winning or losing will be 1 minus probability of that event, that is 1 minus 5 by 11, that is 6 by 11. Done. Pretty simple. Now let us look at the next sum. Now look at number 6. Two players, Sania and Sonali, plays a tennis match. It is known that the probability of Sania winning the match is 0.69. What is the probability of Sonali winning? Which means we need to find the probability of Sania losing, which means probability of Sania not winning. You know, bar I have given will be 1 minus 0.69, which is 0.31, isn't it? Yeah. So probability of Sonali winning, will be 0.31. We know probability of event plus probability of the complement of that event, this event not happening, is 1. So probability of Sania winning and losing will be equal to 1. Am I clear? Number 7. A bag contains 3 red balls, 5 black balls, which means the total number of balls are 8. A ball is drawn at random from the bag. What is the probability that you draw a red ball? Very easy. 3 favorable outcome, 8 total outcome. Done. Number 2. What is the probability that it is not red? Not red. There are 2 ways. You can do 1 minus 3 by 8. That's 5 by 8. Or simply, not red means black, which is 5 by 8. Clear? Now, number 8, I'll just read this sum. Because that's a huge sum, so I'm not in a mood to write that sum. There are 40 students in class 10. So total number of students is 40. Of which 25 are girls. So girls 25. And the others are boys. So boys are 50. No doubt in that. 40 minus 25. The class teacher had to select one student as a class representative. She writes the name of each student on a separate card. The cards being identical. Then she puts cards into a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl and a boy? 2 parts, What is the probability that the name written on the card is the name of a girl? So girl, there are 25 girls, favorable outcome, and total outcome is 40, which is 5 by 8. Am I clear? Boy, 15 out of 40, that's 3 by 8. Done. Now let us look at the next sum. Now look at number 9. A letter is chosen from the word triangle. What is the probability that it is a vowel? Now the sample space, if you say, will be T, R, I, A, N, G, L, E. This is your sample space, isn't it, of the experiment? Now, what is the probability that it is a vowel? So this, these are your favorable outcomes. So probability that you get a vowel, your favorable outcome is 3, and the total number of outcome is 1, 2, 3, 4, 5, 6, 7, 8. So 3 by 8 is your probability. Okay. A letter in English is chosen at random. Determine the probability that the letter is a consonant. Now we know there are, how many consonants are there? Now we have 26 letters in all. Total, out of which 5 are vowel, A, E, I, O, U, and the rest 21 are consonant. So what is the probability that it's a consonant? Will be favorable outcome, that is 21, by total number of outcomes, that's 26. Clear? Now look at number 11. A bag contains 5 black balls, 7 red balls, 3 white balls. A ball is drawn at random from the bag. Find the probability that the bag is red. Find the probability that it is red. Black or white. Black or white. And the last one is not black. Not black. Now the first one, when you talk about red. 7 red. Favorable outcome is 7. Total is 15 if you look carefully. So 7 by 15. Done. Black or white, which means either black or white. So favorable outcome will be 8 by 15. The condition satisfies even if it comes black or white. So the total number of favorable outcome will be 5 plus 3. Okay. Not black. See. Not black means red or white, which is 7 plus 3, 10. So number of favorable outcome is 10 by 15. So that's 2 by 3. This we can do one more way. See, probability of not black. We'll find the probability of black. Probability of black will be 5 by 15, isn't it? That's 1 by 3. So probability of not black, bar I've given, will be 1 minus 1 by 3. That's 2 by 3. Done. We can do anyway. Okay. Now let us look at the next sum. Now look at sum number 12. A bag contains 7 blue balls, 7 blue balls, 8 white balls, and 5 black balls. Okay. So the total number of balls are 20. If the 5 marbles. These are marbles, not balls. If a marble is drawn at random from the box, what is the probability that it will be black? Now first black. Probability that it is a black. Favorable outcome is 5 and total number of outcome is 20. So 1 by 4. Done. Blue or black. So blue or black. 7 plus 5. Blue or black. Favorable outcome will be 7 plus 5, that's 12. Total outcome is 20. So that's 4 3 times, 4 5 times. Not black. Now getting a black, the probability is 1 by 4. So not black, probability of getting not black will be 1 minus 1 by 4. Complementary, So 4 minus 1, that's 3 by 4. Otherwise you can do 8 plus 7, that's 15 by 20. Same result you will get. Green. Now there isn't any green ball. So the probability of getting a green ball, it's an impossible event, has to be 0. Done. Now look carefully. Number 30. A box contains 6 red balls, 6 red, 8 white, 5 green, and 3 black balls. So total number of balls are 8 plus 6, 14. That's 19, 22 balls in total, isn't it? 14, 19, 22, yeah. One ball is drawn at random from the bag. Find the probability that the ball is white. So 8 by 22, that's 4 by 11. Red or black. Red or black, that's 6 plus 3, 9. 9 by 22. Favorable outcome by total outcome. Not green. So it should not be green. So it can be 6 plus 8 plus 3. That's 14 plus 3, 17 by 22. Or you can find the probability of getting a green ball, that's 5 by 22. So not green will be 1 minus 5 by 22. Still the result comes in neither white nor black, which means neither white nor black, which means it has to be red or green. So 6 plus 5, 11. So 11 by 22, that's 1 by 2. Done. Now let us look at the next sum. Now look at sum number 14. I'll read it. A piggy bank contains 150 paisa coin. So there are 50 paisa coin. How many is? 100. 50 rupees 1 coin. Rupees 1 coin. How many? 100. 20 rupees 2 coin. Rupees 2 coin, how many? 20. And 10 rupees 5 coin. Rupees 5 coin are 10 in numbers. So how many coins are there? There are 230 coins. It is equally likely that one of the coins will fall down when the bag is turned upside down. What is the probability that the coin will be 50 paisa coin? See, 50 paisa coin. So the favorable outcome will be 100, isn't it? And total number of outcome is 230. So that becomes 10 by 23, that it is a 50 paisa coin. Done. The first part. The second part will not be rupees 5 coin. Will not be, provided not be rupees 5 coin, which means it can be 50 paisa, it can be rupees 1, it can be rupees 2. So favorable outcome will be 220, isn't it? My total number of outcome is 230, so that's 22 by 23. That is one way. Or you can do another way, that is probability that you get rupees 5 coin is 10 by 230. That's 1 by 23. So probability that you don't get this, is 1 minus 1 by 23. That's 22 by 23. Both are correct. Done. Now, number 15. A carton consists of 100 shirts. So total number of shirts is 100. They're told. Out of which 88 are good. So how many are good? 88. 8 have minor defects. There's some issue, 8. And 4 have major defect. A lot of problem with those shirts. Major defects is 4. Peter, a trader, will only accept the shirts which are good. So Peter will accept good shirts. Okay. Then Salim, another trader, will only reject the shirt which have major defect. The Salim rejects major defect. So he'll take the good one as well as the minor one. Okay. But Salim, another trader, will only reject the shirts which have major defect. One shirt is drawn at random from the carton. What is the probability that it is acceptable to Peter? So what is the probability that you take out the shirt and Peter takes it? See, Peter will take only these shirts which are good. So his favorable outcome is 88 out of total, that's 100. Am I clear? So that's 422 times, 425 times. Done. Next part. It is acceptable to Salim. Now Salim, look carefully. Salim will accept these two which are good as well as minor defect, which means 96 shirts. Okay. So his favorable outcome is 96. Total outcome is 100. So that's 19. Sorry. We cancel by 4, 4, 24, 25. Done. So whatever the shirt comes, Peter accepting that shirt is 22 by 25 and Salim is 24 by 25. Now, one more sum we'll do. A die is thrown once. What is the probability that the number is even and the number is greater than 2? This came in Icse 2009. Icse 2009. A die is thrown. So what will be the sample space? 1, 2, 3, 4, 5, 6. So when you throw a die, the spelling of die is D-I-E. Okay, that's not a wrong spelling. And plural is dice, D-I-C-E. Okay. So when you throw a die, these are your outcomes, sample space. What is the probability? What is the probability that you get an even number, and the probability that you get a number greater than 2? Now look over here. Even number. When you talk about even number, your favorable outcome is 2, 4 and 6. So 3 outcomes are favorable. Total outcome is 6. So that's 1 by 2. A number greater than 2, which means this. So there will be 4 favorable outcome out of 6. So that's 2 by 3. Am I clear? So this was sum number 16. Now in this video, keep it till here. In the next video, we'll do the rest of the sum. Till then, take care. And if you like the video, do not forget to subscribe